All right, welcome to another lesson. In this lesson, we'll be covering Day of the Programmer, an easy rated Hackerrank algorithm question. And this question's kind of funky, a little wordy over here, so take your time to understand it, but of course we will go over it. The gist is that in the year 1918, Russia switched from the Julian calendar to the Gregorian calendar. And in doing so, they lost a bunch of days in their year because according to their Julian calendar, they were on January 31st, and they wanted to switch over on that day. And in order to catch up to the rest of the places that were operating on the Gregorian calendar, they had to jump ahead to February 14th. So essentially, they lost 13 days that year. And of course, this question is about the Day of the Programmer. The Day of the Programmer is the 256th day of any year, no matter what. So essentially, Russia has three ranges, or three different conditions that can be thought of. They have their Julian calendar timeline, where there's a 256th day of the year, their unique year itself, where there's a 256th day of the year, and the Gregorian calendar, 256th day of the year. So in this question, they indicate that we'll be analyzing years from 1700 to 2700. And the output of, the input will be the year, and we want our output to be the date in this format: day, month, year. Okay, so let's hop over to Replit and get to work. I did a little bit of work for you guys already. Basically just figured out what days what calendar days the 256th day would actually land on. It's actually the same day for both the Julian and Gregorian calendars. In a regular year, it's September 13th, and in a leap year, it's September 12th. And then in our unique year, it lands on September 26th. And we'll see that we want three different conditions to figure out what day we're going to land on. And that's because the leap years of the Julian calendar and the Gregorian calendar do not line up. The Julian calendar follows this one condition where a leap year happens every 4 years. So if the year is divisible by 4, it is a leap year. And the Gregorian calendar is a little bit more complicated. It has to follow either of these two conditions. So we'll dive into that a little bit deeper as we get to it, but let's start writing our code. So what do we want? I also included this little line right here, return the date, because if you read through here, it says print, but what you actually want to do to get the question correct is return. And you can return a string too, actually. We'll add that as well, string. Okay, so what would our string look like? We would want the date, we could set a variable date to be equal to, what would it be? We want the format to have the day. Like I said, it can be a string, the month, and then the year. So let's type that out in an F string. We would do just like this, day, month, year. And we actually need to move this date down because otherwise Python doesn't know what to put in here. It needs these variables established before we can actually add them to our string. Okay, so there is one other thing we can do here. We can actually set the month to 09 because we know it's always going to be September. In any of these conditions, the 256th day always lands in September. But the day, we don't know what day we're going to land on. And like I said, we want to store that value up here and add it to our date down here. So we're going to need to add some conditional statements in between our day variable as well as our date variable. Okay, so like indicated up here, we're going to need some conditional statements that satisfy those three conditions. So if the year is less than or equal to, if 1700 is less than or equal to year, and year is less than 1917, it will follow one condition. Let's just write out all three of our conditions right now, and then we'll dig a little bit deeper into figuring out the leap years. Okay, so there's our first if. Then we have an elif. Year, as indicated up here, is equal to 1918. That's going to be the only year that follows that conditional statement. 1918. Let's get our format correct. And then last statement, elif, what would it be? 1919 is less than or equal to year. Oh no, you know what we can do? We can do 1918 is less than year. It's less than or equal to 2700. Get that formatted correctly. Okay, so let's start up here with our Julian range. So, we need to figure out if it is in this condition, if the year falls within this condition, if it's a Julian year, is it a leap year or not? Because that's going to decide whether we're going to set the date to September 13th or September 12th. So how do we determine if the year is a leap year? As indicated in the given information, leap year divisible by 4. So if year modulo 4 equals 0, we're going to set day equal to 12. And it's that simple. Math here checks out. If the year divided by 4 gives you a modulo of 0, that means it's evenly divisible, and we'll set our date to 12 because we know it's a leap year. And then else, because that's the only condition, there's really only two conditions, if it's a leap year, if it's not a leap year. Else, we set the day equal to 13. Okay, here's our second condition. This is the unique year of 1918. What happens in the year 1918? Well, there's nothing more conditional than that level because it's just 1 year and there's only one date that the 256th day occurred on. So we can just go ahead and set the day equal to 26. All right, last condition, our present day dilemma, the Gregorian calendar. Leap year is a little bit more complicated for the Gregorian calendar. And luckily, they give us the two conditions here. And the key term here is either. So we can write an or statement. Either the year is divisible by 400, or it's divisible by 4 and not divisible by 100. And the way it's written here is kind of a giveaway of how we'll write the code. It could be asking in a different manner that can make this more complicated. You'd have to figure it out on your own. But first condition is nice and easy, very simple, very similar to this condition up here. It's just using year modulo 400. I believe it's 400, correct? Yes. No. Divisible by 400, yes. Sorry, the note I wrote was wrong. If year modulo 400 equals 0, we satisfy the statement. Or, a little bit more complicated, if, yeah, I think that's right. Or, parentheses, because this condition is a little bit more complicated, it's got two parts to it. If year modulo 4 equals 0 and year modulo 100 is not equal to 0, that also satisfies the statement. And really, this is just how you would write in code exactly what is given to us here. So I hope that makes sense. If not, do some printing, do some tests, and I'm sure you'll get it figured out. So if it satisfies this statement, it is a leap year, which means we set our date at 12, and else, the other condition, we are going to set our day equal to 13. Okay, and that is basically it. So let's go ahead and print Okay, so we're gonna actually set our date up, get the information in there, and then we're going to print the date just to see if our work checks out. Like I said, we're gonna want to return it in the end. This is just some testing, some debugging. Okay, so in the year 1916, we see that it is a leap year. We can figure out on our own that 1916 is Gregorian. And if we really wanted to indicate that, we could write like print Gregorian or anything like that, but we'll just leave it as is for now. So not only is it Gregorian, but it's a leap year. Let's test 1917. Oh, we actually get a bug. What happened here? Okay, sorry guys, I noticed that I typed in the wrong year here. We need to be less than 1918, not less than 1917, because we want it to include 1917. If you wanted to, you could do 1917. It's less than or equal to. But for our sake of this example, we'll just use 1918. Okay. So we know 1918 works. I just checked that out. There's the Gregorian example, September 26, 1918. Let's go back down and check 1917. Standard Gregorian year, September 13th. And then let's also check 1919 to enter the Julian years. There you go. A standard Gregorian day. Okay, so let's go ahead and move all this over to our Hackerrank input system, get everything in the format that Hackerrank requires. Okay, bear with me. Good. That. Okay, we can remove the print and we'll actually just return it right here. Now we need to move this up a little bit and include our R. All right, let's run the code. Great, so it satisfies the two test examples and test all the rest of the test cases. It got plenty here, so if this works, it should prove that we've got a successful algorithm. I think this is a sign that I need a new computer. Okay, great, there we go. Passed all the tests. So I hope you enjoyed. I hope it's clear. If you have any questions, do not hesitate to drop them in the comments. If you enjoyed, please like the video and pop the subscribe button. I'll be posting these pretty frequently. So yeah, thanks for watching.